All right, this is pretty much a review. Pythagorean theorem, we've talked about it throughout the year, here and there. You know my method of the adding Pythagorean theorem and then the subtracting. Basically, if you have two legs and you're trying to find the hypotenuse, you're going to use the adding Pythagorean theorem. Square root of 5 squared plus 12 squared, punch that in, and you'll get 13. Okay, the subtracting is whenever you have the hypotenuse as a number and you're trying to find one of the two legs. So you do the subtracting Pythagorean theorem where you put the hypotenuse first, the biggest number, minus the 15 squared, and that'll get you, oh my gosh, okay, 8. Yeah, that's 8. That's right. Let me see. I've told you what a Pythagorean triple is, right? Where three numbers are whole numbers and it's a right triangle. Okay, if it's a right triangle, there are certain ones that we use as teachers, and the multiples of those numbers, like we did 5, 12, and 13 here, this was 8, 15, and 17, and then if you multiplied it by 2, then you'd have a 6, 8, 10. Multiplied this by 3, you'd have a 9, 12, 15. So all of these numbers represent three whole numbers that will create a right triangle. Okay? So let's use the Pythagorean theorem. Okay, is this the adding Pythagorean theorem or the subtracting to find x? Okay, adding because we're trying to find the hypotenuse. This is the normal way. Okay, so you put square root of 81 squared plus 108 squared. Oh goodness. Get the, oops, clear. Let me see. 80, whoops, I messed up. 81 squared plus 108 squared, 108 squared, enter. It's 135. Okay, so x is 135. So did it make a Pythagorean triple? Yes, it did. These three numbers are whole numbers, yes. Okay. This one, you'd have to use the subtracting Pythagorean theorem because this one is the hypotenuse, right? So you'd say 8 squared minus 4 squared to get x. So you punch that in, second radical, 8 squared minus 4 squared, and you get 6.9, okay? So x was 6.9. Is this a Pythagorean triple? No, because there was a decimal. Okay? Next page. Okay, a telephone pole support cable attaches to the pole 20 feet high. So you've got, you know what a telephone pole kind of looks like that has wires on it. Pretty soon I don't think we'll have any of those. All right, so there's a cable that attaches to the pole 20 feet high. So 20 feet high is straight up this way, right? If the cable itself is 25 feet, it's kind of like it's holding it up, right? You'd have one on the other side too, but I'm not going to draw that one. So you've got this right triangle. All the Pythagorean theorem stuff has to do with the right triangle, right? Okay, so if the cable is 25 feet, then how far from the bottom of the pole right here, okay, to where the cable attaches to the ground. There's some kind of little peg there or something. So they want to know this, okay, bottom of the pole to where the pole attaches to the ground, okay, the cable attaches to the ground, sorry. So this is the hypotenuse, so you use the subtracting Pythagorean theorem. 25 squared minus 20 squared is going to be 15, okay, so this is 15. Okay, now if we want to know if these are right triangles, then you do this. You use the Pythagorean theorem, a squared plus b squared equals to c squared, and then you see if it's equal on both sides. So the 26, the longest one, goes over here, 26 squared, and then just checking to see if I'm on screen. So this is 14 squared plus 22 squared, right, is equal to 26 squared. So 14 squared I know is 196, and well, I'm getting old. Okay, 22 squared is 484, of course. I just wanted to be sure, I didn't want to be wrong. Okay, and then 26 is 26 squared, I'll guess, whoops, 576 or 676, I can't remember. 26 squared is 676, yeah. Okay, so that's that. So if this adds up to 676, then they're equal on both sides, right? So 196 plus 484. Okay, 196 plus 484 is definitely not 676. Okay, so this was 680 and it was not equal to 676. So is this a right triangle? No, but it's very close. Okay, this one right here, this is the hypotenuse. Okay, we're going to take that over here, 3 radical 34. We're going to take all of that and square it, and you can stick that into a calculator. 9 squared plus 15 squared, or I could show you how to do it where you write it down twice and multiply, right? Remember we talked about that last time? Okay, so you know this is 81 and this is 225. Okay, so parenthesis 3 second radical 34. Y'all are so much faster than me at this. Okay, I'm gonna get outside of that, put the parenthesis, and then hit the x squared again. Bam. Okay, 306. Okay, so is this 306? Yes, it is. So 306 is equal to 306. So what does that tell you about this triangle? Yes, it's a right triangle. I'll just say RT. It's a right triangle. Okay. All right, let's go down here. There are a lot of problems that have right triangles in them, where they'll talk about a yard and they'll put a diagonal on it, a field, a TV, a rectangle of any kind, and you've got a right triangle, right? And you're trying to find the hypotenuse, which is the diagonal distance across the field. Okay, so they say the width is 15 and this length is 20, then what's this one? Well, it was 25 a minute ago, so I'll write that down, but basically you would have done the adding Pythagorean theorem, which is 15 squared plus 20 squared, and that was 25, okay, for this distance. A square has a diagonal and it's a right triangle, and if they tell you one side, then they've told you all of them. Okay, so this is a 6 and this is a 6, so you do the square root of 6 squared plus 6 squared, and that'll give you a decimal. Let me see. Second radical 6 squared plus 6 squared is 8.48. I'll say 8.5. Okay, so that's the diagonal distance, is 8.5. Okay, equilateral triangle. Okay, isn't that a right triangle? Whenever you have this height, okay, they use this all the time in geometry because it's very symmetrical. And so this side would be 8 and so would this, but wouldn't this be 4 if it's half of 8? Okay, so if you want to find the height, then you do the square root of 8 squared minus 4 squared, right? Because isn't that the hypotenuse? Right, so you punch that in, second radical 8 squared minus 4 squared, bam. Okay, 6.9 again. So this is 6.9 is the height. Okay, 6.9. And then the last one, sometimes they'll just give you this and say find the height. And this is the exact same problem, right? And then you got to put 3.5 here because it's half of 7. So you're going to do the square root, if you want the height, of 7 squared minus 3.5 squared. Okay, which is no big deal. It's just doing the same problem again. Okay, 7 squared minus 3.5 squared, bam. Okay, so that just looks wrong. Oh, there's a 6 in front. What's that doing there? Okay, let me see. 7 squared minus 3.5 squared. Better. 6.06, we'll say 6.1. Okay, it should never be bigger than the hypotenuse, right? Okay, well, we're done. Have a good day.